one, we need to determine whether the series is convergent or divergent. Clearly show a reason by a valid test. If it is convergent, find its sum. So here um, we have an equal to 2 raised to n by 5 raised to n, and if you take an plus 1 will be 2 raised to n plus 1 by 5 raised to n plus 1. So an plus 1 by an will be equal to, so 2 raised to n plus 1 by 5 raised to n plus 1 by 2 raised to n by 5 raised to n. So that is going to be equal to 2 by 5. So limit n tends to infinity. An plus 1 by an will be equal to limit n goes to infinity 2 by 5. So which is 2 by 5, which is less than 1. So therefore the series will converge by ratio test, and this is also of the form summation n equal to 1 to infinity x raised to n, or this is actually a geometric series. So here if we take summation n equal to 1 to infinity 2 by 5 whole raised to n, this will be equal to 2 by 5 plus 2 by 5 whole square plus 2 by 5 whole cube plus etc., where r is less than 1. So the sum of the series will be a by 1 minus r. So here a will be 2 by 5 and r is also 2 by 5. So that will be 2 by 5 by 1 minus 2 by 5. So that will be 2 by 5 by 3 by 5. So we will get 2 by 3 as the sum. And summation n equal to 1 to infinity 2 raised to n by n square. So if we take an will be 2 raised to n by n square, and an plus 1 will be 2 raised to n plus 1 by n plus 1 whole square. So an plus 1 by an will be 2 raised to n plus 1 by n plus 1 whole square by an. So we will get n square by 2 raised to n. So we will get 2 into n square by n plus 1 whole square. So if we take limit n tends to infinity, an plus 1 by an, so that will be equal to limit n tends to infinity to n by n plus 1 whole square. So that will be 2 times limit n goes to infinity. So this can be written as 1 by 1 plus 1 by n whole square. So the limit value will be equal to 1. So we'll get 2. So this is greater than 1. So therefore by ratio test the series will diverge. So the limit value is greater than 1. Series diverges in this case. And next one, for the series summation n equal to 1 to infinity minus 1 whole power n by n plus 2, determine whether it is convergent or divergent. If the series is convergent, then do not find its sum. So here we'll use the alternating series test. So we have an equal to 1 by n plus 2. So an is positive, and if we take an plus 1 will be 1 by n plus 3. So 1 by n plus 3 will be less than 1 by n plus 2, so which is equal to an. So an plus 1 will be less than an. So the sequence will be decreasing, and if we take limit n goes to infinity 1 by n plus 2, so that will be equal to 0. So we'll get limit n tends to infinity an equal to 0. So it satisfies all the three conditions of alternating series test. So by alternating series test, the series converges. So by alternating series test, the series converges. And next one, we need to determine the sum of the series summation n equal to 0 to infinity 1 by n square plus 3n plus 2 Now 1 by n square plus 3n plus 2 will be equal to 1 by, so this can be factored as n plus 1 into n plus 2. Now by partial fraction we can write this as a by n plus 1 plus b by n plus 2. So equating the numerators, we'll get 1 equal to a into n plus 2 plus b into n plus 1. So if we put n equal to minus 1, we'll get so here it will become 0, here we'll have 1, so a equal to 1 will come, and if n is minus 2, we'll get, so here we'll get minus 1, so minus b equal to 1. So a will be 1 and b will be minus 1. So the series can be written as summation n equal to 0 to infinity 1 by n plus 1 minus 1 by n plus 2. Now we know that sum of a series will be limit of the sequence of partial sum. So let us take sequence Sn to be the sequence of partial sums. So summation n equal to 1 to infinity, an is same as limit n tends to infinity Sn. And now Sn will be equal to a1 plus a2 plus etc. an. So that will be the sum of first n terms of the series. Now here a1 will be 1 by, so when n is equal to 1, we'll get 1 by 2 minus 1 by 3. And the next term a2 will be 1 by 3 minus 1 by 4, and a3 will be 1 by 4 minus 1 by 5. So on, the last term will be 1 by n plus 1 minus 1 by n plus 2. Now we can see that these terms will cancel out, all the terms in the middle except 1 by 2 and 1 minus 1 by n plus 2 will cancel off. So we'll get Sn as 1 by 2 minus 1 by n plus 2. So therefore the sum of the series will be equal to limit n tends to infinity Sn. So that will be limit n tends to infinity 1 by 2 minus 1 by n plus 2. Now this limit will be, as n goes to infinity, 1 by n plus 2 goes to 0. So the limit will be equal to 1 by 2. So the series will be converging to 1 by 2. Now the series in part B, that is of the form summation n equal to 0 to infinity x raised to n by n factorial. So this series will be converging to e raised to x. So in place of x we have 2 by 5. So therefore summation n equal to 0 to infinity 2 raised to n by 5 raised to n factorial will be equal to e raised to 2 by 5. So that will be the sum of the series. Next problem, we need to determine the interval of convergence of the series. So we'll evaluate limit n tends to infinity modulus of an plus 1 by an. So that will be limit n goes to infinity modulus of minus 1 whole raised to n plus 1 x raised to n plus 1 by n plus 1 4 raised to n plus 1, then n 4 raised to n minus 1 whole power n x raised to n. So we'll get limit n goes to infinity. Now the minus sign will go off since we have modulus. Then remaining we have mod x n by n plus 1. Then there will be a by 4. Now taking the limit as n goes to infinity. So if we take n outside from numerator and denominator, we'll get limit n goes to infinity mod x by 4 into 1 by 1 plus 1 by n. So taking the limit as n goes to infinity, this will be mod x by 4. So therefore the series will converge if mod x by 4 is less than 1. So that implies mod x must be less than 4. So it will converge between minus 4 and 4. Now let us check at the endpoints at x equal to 4 and minus 4. Now when x is equal to 4, we will get summation n equal to 1 to infinity. So when x is 4, we'll get 4 raised to n here. So 4 raised to n will cancel off. So we are going to get minus 1 whole power n by n. So this is convergent series. So at x equal to 4, it converges. And at x equal to minus 4, we'll get summation n equal to 1 to infinity. So when minus 4 whole power n comes, so minus 1 whole power n into minus 1 whole power n will be equal to 1, and 4 power n will cancel off. Remaining we'll be getting summation 1 by n, and this will be divergent. So at x equal to 4 it converges, and at minus 4 it diverges. So the required interval will be open interval minus 4, then closed interval 4. So minus 4 is not included, and 4 will be included. And the next problem, we need to determine the Taylor series about x equal to 0. You may apply any general series that you know. So we know that summation n equal to 0 to infinity x raised to n, so which is the geometric series, so that will be equal to 1 by 1 minus x. Okay, 1 by 1 plus x will be, so if we replace x by minus x, 1 by 1 plus x will be summation n equal to 0 to infinity minus x whole power n. So this can be written as 1 by 5 into 1 plus x by 5. So we have 1 by 1 plus x by 5, that is of this form, where in place of x we have x by 5. So this will be equal to 1 by 5, summation n equal to 0 to infinity. So we will get minus x by 5 whole raised to n. So that will be summation n equal to 0 to infinity. So we will have minus 1 whole power n x raised to n. And here there is a 5 raised to n, and there is a 5 here. So we will get 5 raised to n plus 1. So that will be the required series. Now for this one, this will be equal to, okay, so let us call f of x to be log 5 plus x. Now if we take f dash of x will be 1 by 5 plus x. So we already got the series for 1 by 5 plus x. So this will be equal to summation n equal to 0 to infinity minus 1 whole power n x raised to n by 5 raised to n plus 1. And now upon integrating, so we'll get f of x equal to summation n equal to 0 to infinity minus 1 whole raised to n x raised to n plus 1 by n plus 1 5 raised to n plus 1 plus c will come, and here f of x will be, so this will be equal to log 5 plus x. Now when x is equal to 0, this entire term will become 0. Now we need to find what is the value of c. So put x equal to 0. So when x equal to 0, we will get log 5 equal to 0 plus c. So therefore c will be log 5. C will be equal to log 5. So therefore log 5 plus x will be equal to log 5. Now replacing c, will get log 5 plus summation n equal to 0 to infinity minus 1 whole raised to n x raised to n plus 1 by n plus 1 5 raised to n plus 1. So this will be the required series. And next one, we have